recording. Yes, it's recording now. All right. So yeah, I was saying, guys. So for the second test, let me turn on my pencil. All right. Yeah. So the second test. So it's gonna cover chapters. So we have chapters. There is a chapter 6. Chapter 6, 7, and 8. So first we have chapter 6. So so in homework, I think number 5. Number 5. So we had problems about the chapter 6. There is chapter 7, which was covered before the spring break. So that would be homework number 6. 6, and then there's chapter 8. And so that would be homework number 7, which is due this Friday. Number 7, due this Friday. All right. So, and the final, of course, well, the final is supposed to cover everything. So it's gonna be, so the final is gonna cover like all the chapters, like from chapter 2, 3, 4, 5, 6, 7, and 8, and probably chapter 9. I think we're gonna cover. I'm gonna do like probably 2 sections for chapter 9 tomorrow or Wednesday. And then yeah, but anyway, so as I said, so today we're gonna just you know, we're gonna start like the review for the test and for the final. And so I'm gonna go over homework number 6. Okay. So today, so we're gonna discuss homework number 6. Okay. So that's, again, as I said, that's chapter 7. So the main sections in chapter 7, so there are, in chapter 7, there are like 3 main sections. There is a section 7.3, right? So in 7.3, that's where we convert variable x to z to the variable of the standard normal distribution. So in 7.3, we convert x to z. And 7.5, so that's where we converted x bar, the mean, the sample mean x bar to z. And then there is section 7.6, where we converted like the number of successes, which is the variable of a binomial distribution, to z. So in 7.6, we converted r to z. So again, r here, that's the number of successes in a binomial distribution. Number of successes. All right. So these are the main sections of chapter 7. All right. So let's start with the first exercise. Okay, exercise 1. So the keyword in this chapter 7. So for section 7.3 and 7.5, they are both about normal distributions, right? So sections 7.3 and 7.5. Okay, both sections are about normal distribution. So this is, so both are about normal distribution. Okay. Is there any question for me? Let me see the chat. Do you hear me, guys? For some reason, Zoom stopped working.
Yes, I can hear
Okay.
you.
Yeah, thank you. Because I don't know what happened, but just it stopped working. Yeah. All right, thank you. So let me share again my screen, I guess.
Hi, Professor. I just came in.
That's Destiny.
Jessica.
Mm-hmm. All right. All right. Sorry about that, guys. For some reason, I don't know why it stopped working. Okay. So do you see the board?
Yes.
Yes. All right. Thank you. Yeah. So I was saying. So today we're gonna discuss homework 6. So homework 6 actually covers chapter 7. So we have three main sections in this chapter 7. There's 7.3, 7.5, and 7.6. 7.3 and 7.5 are about both are related to normal distribution. Okay, so both. Oh. So both 7.3 and 7.5 that are related to normal distributions. So the main formulas in the 7.3, all you need to know is how to convert variable x to z. You have a normal distribution, right? We're talking about normal distribution. So the key word here is a normal distribution. So you have normal distribution, and then you want to compute some probability, of course. But to compute the probability, you have to convert you need to convert your variable to z. So to convert the variable to z, you need to use the following formula. So your z would be x minus mu, the population mean, over sigma. Okay, so that's for 7.3. In 7.5, you need to convert x bar, the sample mean. It's 7.5, that's the central limit theorem. And in central limit theorem, we discussed how to convert x bar, the sample mean, to z. So that's x bar minus mu over sigma. So that would be yours. All right. So if you take, for example, first exercise 1. Exercise 1 in the homework number 6. Homework number 6, of course. So it says there's a thickness measurements of Asian prehistoric Native American port charts, the discovered, etc. And is normally distributed. So this is a thickness measurements of port charts, okay, etc. It says it's normally distributed, right? It says normally distributed. So the keyword here is normally distributed. So we have a normal distribution. So we are talking about this variable x. So we have this variable x, which is normally distributed. So the variable x here, guys, so we are interested in the thickness measurement, right, of the port charts. So the variable x, of course,
in here.
Say again. That I guess it's not. I guess it's not a question for me. All right. Yeah. So I was saying. So the variable x, because we are interested in thickness measurement of the port charts. So the variable x is going to measure the thickness of your, so variable x here, x, that's the thickness of the plot chart, right? Anyway, so but as I said, the keyword, whenever you see the normal distribution, when it says like normal distribution, right? So we are talking about variable x, which is normally distributed, right? And then with a normal distribution, there is a population mean. Whenever you have a normal distribution, there is, so you will see there is mu, the population mean or population average. So like in this problem, the mean mu is 5. It says the population average is 5.1 millimeters. Okay, and then there is the population standard deviation sigma, it's 0.9. So you see, guys, there is this mu and there is this sigma, right? So, and that's all you need to convert your variable x to z, right? And the variable, when you convert x to z, what you need is mu and the sigma, the population mean and the population standard deviation. That's how we convert x to z. So, the keyword, as I said, it's a normal distribution. You have mu is given, sigma is given. So once you have mu and sigma, then you can convert your x to z. So now, first question, it says, one, what's the probability that the thickness is less than 3.0 millimeters, right? So again, x, variable x, that's the thickness of your report chart, right? You want x to be less, you want the thickness to be less than 3.0 millimeters, right? So we want to x, the probability that x is less than, so you wanna compute the probability that x is less than 3.0 millimeters. Okay. Now less. The symbol for less is, so that would be x less than 3.0, right? This is less. Okay, so you wanna the thickness to be less than 3.0 millimeters. So how do we compute such probability, right? So as I said, when you have a normal distribution and you wanna compute the probability, you have to convert this your x to the standard normal distribution. The standard normal distribution of the variable is z. So you need to convert x to z. Okay. So you want to compute the probability of normal distribution. You have to convert your normal distribution to the standard normal distribution. So you need to go from x to z. Okay. Does this make sense to you guys? All right. Let me see the chat.
What's the other, Professor, the other symbol with the line under it, isn't it? That's like more than or something like that? Not more than.
You mean like, you mean like this?
Yeah, that one.
Yeah, this is less or equal.
Oh, okay, that's the one.
Less or equal.
Mm-hmm.
But I mean, for there, for us, there's no difference. Like when you compute the probability, there's there is no difference between less or equal. Okay, both are the same actually. But yeah, that would be less or equal. All right. So that's x less than 3.0, and yeah. So you see normal distribution, then you need to convert your normal distribution to standard normal distribution. You need to go to standard normal distribution. And so in other words, you want to go from x to z. You want to go from x to z. All right, so then all you have to do is to convert this x to z. Okay, you need to convert x to z. So probability that x is less than 3.0. You want to use z now instead of x. But the thing is, so this 3.0, that's a value of x. This is a value of x. This is your x, 3.0. That's your value of x. And you want to convert this value of x to a value of z. So to convert to value of z, we need to use this formula right here. So it's the value of x, which is 3.0, minus the mu over sigma, right? So whenever you see like mu and sigma are given in the problem, so that's just at some point you need to convert your x to z, right? You need to use your mu and sigma. So there is mu, it's 5.1, and there is sigma, which is 0.9. So all we have to do is take the 3.0 minus mu minus the 5.1 over the sigma, 0.9. Okay. So again, this 5.1, that's your mu, and this 0.9, that's the sigma. And that's how we convert x to z. So this is exactly our section 7.3. That's how we said how we compute the probability of a normal distribution. So, all right, so now it's just, you subtract in the top, and then you subtract in the top, that's negative, sorry, what is it? Negative 2.1. So it's negative 2.1 over 0.9. You divide, don't forget your negative. There is a huge difference between negative and positive here. It's important that you have the right sign. So it's negative 2.1 over 0.9. And that's actually, so z less than negative 2.33 actually. All right. Now, what do we do with this negative 2.33? This is why do we bother ourselves to convert this x to z? The thing is, the thing with the z is that we have a chart for z, and we can use the chart to find this this probability, right? So this is z less. So here it's important that z is less, because z is less, okay, then like here it's less than negative 2.33. So this is the area to the left of negative area to the left, sorry. So this is the area to the left of negative 2.33, right? When you have less, that's the area to the left, okay? And the areas to the left are given by the chart or the table 3. Areas to the left are given by chart or table number 3. All right, so our z is negative 2.33, right? Nearest 10th, it's negative 2.3, and nearest 100th, it's 3, right? So nearest 10th in negative 2.33. So 10th, that's the first 10th, that's the first digit after the decimal point, right? The first digit after the decimal point, it's 3, right? So nearest 10th here would be negative 2 point, and we stop at the first digit after the decimal point. Nearest 100th, just take the second digit after the decimal point, 100th, right? So second digit, it's just 3, right? It's again 3, so it's nearest 100th would be 03. Okay, just take the second digit, which is 3. All right, so that's my nearest 10th, that's my nearest 100th. Now I can use my chart because this is the areas to the left. So let me share with you the chart. It's right here, right? So you go to the chart number 3 or table 3. Here's table 3. All right, as we said, there's 2 pages in this chart. First page, your z is negative. You see the first column? Your z is negative. Negative 3.4, negative 3.3, negative 3.2, etc. The second, next page, that's positive z, right? So that's why I said negative and minus here. There's big difference between negative and minus, right? The values are not the same. They are completely different. All right. So in our case, it's negative 2.3, right? So we need to go all the way down. This is the first, as you can see, first column. Z is, so we have negative 3.4. So we need to go all the way down to negative 2.3. And then in negative 2.3, we need to go to the column where the nearest 100th it's 3. So yeah, so any guess what will be the answer here for negative 2.33?
Zero 0.099.
Yes, the 0099. Absolutely, thank you. So the probability that z is less than this negative 2.33, it's 0.0099. Convert to a percentage. So of course you need to you need to move your decimal point to the right by 2 places. So that will be 0.99%. So here 2 digits to the right. Yeah, 2 places. So because we multiply by 100. Yeah, so yeah, that's the answer. So what we are saying is find an answer. The probability that the thickness is less than 3.0 millimeters is 0.99%. It's less than 1%, right? Sorry. Yeah, it's less than 1%. Okay. Any question, guys? So you see, when you read the problem, first keyword, of course, is normally distributed. So we are talking about normal distribution. Second keyword I would say is you have your mean and the standard deviation. You have your mu and sigma. Once you have mu and sigma, right, then you can convert your your variable to the z. And I mean, usually, guys, you would have like something like less than a number or more than a number or between 2 numbers. Right? That's like the standard problem in this case, right? So with this section 7.3, when you convert this x to z, so I mean, most of the time you're gonna have like questions like which says like the probability is something that that is less than some number or more than another number or between 2 numbers, right? That's like the 3 cases we have. So this is the case when it's less than. Your x is less than. The second case is when it's more than or larger than or greater than. So that would be number 2 here, right? This is number 2.
I have a question.
Yeah, please.
So the normal distribution, always we're converting x to z. If it says it on there?
Yeah. Yeah,
Okay.
so yeah. With normal distribution, whenever you have the normal distribution, that's how we compute the probability of normal distribution. And we convert x to z because we have the chart that we can use to find the probability of z. The chart gives you the probability of z. So you need to go from x to z. And once you go to z, then you can use the chart.
And what if it doesn't say normal distribution in there?
Well, so then that would be probably a problem about binomial distribution. So for example, in this, like in this homework, if you check, for example, exercise 2, it says that x has a normal distribution. So it's again a normal distribution. Exercise 3, if you take exercise 3 and 4, right? So like in 3 and 4, it's about books, right? It says books sold in the bookstore, etc. It doesn't say normal distribution, right? So in general, what we have here, like in this chapter 7, either you see there is a normal distribution, or if you don't see a normal distribution, then that will be probably a binomial distribution. Okay, and I'm gonna discuss a binomial distribution in the exercise 3 and 4. Okay, so
Okay,
what I'm
thanks.
saying again, what I'm saying is either, so if you see normal distribution, then normal distribution, you see the word normal distribution, then yes. So probably you have to convert x to z, right? And probably like the problems or the questions, you have like something like less than, more than, or between that, between 2 numbers, right? So because then if it's less than, then it means like x is less than some number, more then x is more than some number, and then there is a third case where x is between 2 numbers. Okay, if you don't see the normal distribution, so you don't see the normal distribution, then that will be probably a binomial. Probably it's about the binomial distribution, and that will be a 7.6, and that's what I'm going to discuss now. I mean, not now, but I mean for exercise 3 and 4. So this would be binomial. If you don't see the normal distribution, then it's probably about binomial distribution. All right. And binomial distribution, that's another, well, I'm going to explain the binomial distribution later in the exercise 3 and 4. All right. so number two, your axis or the thickness is more than 7.0. Yeah, 7.0 millimeters. So you want to X to be, you want to find the probability that, right? You want to find the probability. It says, what's the probability? So that's a capital P of what? Well, it says the thickness is more than. So thickness, that's my variable. I'm interested in the thickness measurements, right? So that's X. I want X to be more than. More than 7, more than 7.0. Okay. Now, the symbol for more than, that will be this. So this is X more than. This is more or larger or greater than 7.0. Okay. Anyway, but the thing is, all right, well, first, as a first step, always, as a first step, you convert X to Z, right? That's like always the first step. So we convert X to Z. So let's convert this X to Z. The same formula, right? So this 7.0 minus mu, it's given 5.1 over sigma, which is 0.9. All right, so again, this is mu, and this is sigma, all right? And then, yeah, so subtract first. Well, 1.9 in the top, 0.9 in the denominator. You divide, I think that'll be 2.11 or something. Yeah, 2.11. Sorry, this is Z. I'm sorry. This is, of course, Z. I'm sorry. I convert X to Z, of course. So, yeah, Z more than 2.11. Okay, so this is more. Now, there is a problem with more. What's the problem? It's not as, so here at this, now once you are done with this conversion from X to Z, you are supposed to use the chart, right? That's what I did like here. I converted my X to Z, I got this negative 2.33, right? And then I use the chart and then I got my answer. That's when you have less. When you have more, there is one more thing to do. Because more, the problem with more is that more than 2.11, that will be the area to the right of 2.11. Okay, so here more than 2.11. So that will be the probability that Z is more than 2.11. That will be the area of the region, the area of to the left of 2.11. Sorry, to the right of, area to the right of 2.11. Okay, so more, that will be the area to the right. Less, that's the area to the left. Now, what's the problem with the area to the right? The problem is the chart doesn't give you the area to the right. It gives you only the area to the left. Okay, so the chart, or table feed, gives us the area to the left, not to the right. Areas to the left. To the left. So that's when you have like less than, right? So because the chart gives us the areas to the left, and here I want to compute this area to the right because it's Z is more, right? When I say area to the right, because Z is more, so you know, you have your number line. This is your Z, 2.11, and this is your distribution. This graph is your distribution, and I want to find Z is more, right? Z is more, so that's more, greater or larger than 2.11. So it's on the right side of 2.11. So that's the area to the right, okay? Now, the thing is, as I said, the chart gives us the areas to the left, not to the right. But what's the relation between the areas to the left and the areas to the right? The thing is, the area to the left plus
0.5, right?
No.
Oh,
So we
is
take
it?
the area to the left plus the area to the right, that will be 100%.
Oh, okay.
Because yeah, the area of the region under the graph, the total area is 100%. The left plus the right, it's always 100%. So if you have the area to the right, then that will be 100% or 1 minus the area to the left. Okay.
Oh, okay, I was confusing the other formula because there's
Yeah,
one that we
yeah,
had.
yeah.
Okay, okay.
That's a 7.1, but actually 7.1 is not. I mean, this is like more general than what we did with the 50% and the
Okay.
the section 7.1. But yeah, so the idea is that the area to the left
Can you?
plus the area to the right, that's 100%, and that's 1. That's always 100. That's 1. Okay. So this is, I want to find this area to the left, to the right. So this probability that z is more than 2.11. That's area to the right. So if you solve for the area to the right, that would be 1 minus the area to the left. And the area to the left, that's z less. Z less. That's area to the left. Z less than 2.11. Right? This is z larger. So more than 2.11. So that's the area to the right. This is the area to the right of 2.11. So that would be 1 minus the area to the left. Right? So that's the problem with whenever you have like probability of x more than a number. You have this extra step, right? Where you convert this area to the right to the area to the left. Now, once you convert to the area to the right, to the area to the left, then now we can use the chart. So that's 1 minus, and here I can use my chart. Probability that z is less than 2.11. So this is the area to the left. Nearest tenth, of course, that would be 2.1. And 100th, that will be the 1 here, right? So we go to the chart, 2.1. So it's positive, right? So it's not the first page, but the next one. So it's 2.1, and then 100th, it's 1. So we need to go to 101. So then the answer, that will be 98.26, right? 98.26. So this is, oops. Sorry about that. I don't know. Okay. Okay, yeah. So it's 98.26. So when we say 0.9826, of course that's 0.9826, which is equal to 0.01 and then 74, I guess. Okay. The difference, it's 0.0174, and if you want to convert this into a percentage, you just move your decimal point 2 places to the right. So that's 1.74%. All right. So that's the probability that the thickness is more than 7.0 millimeters. It's 1.74%. Any question, guys? So you see, so that, as I said, that like 3 cases. Whenever you see, so normal distribution, and you see like you want to find probability of something less than a number or more than a number or between them, between 2 numbers, then the idea would be to convert this x to z and then use the chart. Okay. Now there's a third case. So this is when your z is more or x is more. So the third case, it says probability that the thickness is between 3.0 and 7. So we want to find the probability that capital P of the probability that x is between 3.0 and 7.0, right? That's what we want to compute. All right, so what's this? This is probability that, so x between 2 numbers, the notation would be like this. So we have 3.0 in the left and 7.0 in the right. So x is between these 2 numbers, okay? All right, once you write down the probability, right? Then, of course, you need to convert your x to z. That's always the first step. always. First step, convert x to z. Okay, so this is probability that x, sorry, z now. It's z now. So it's 3.0 minus mu over sigma, 0.9. And the other side, or the other hand, or on the right side, it's 5.109. So again, guys, this is mu, and this is sigma. Mu and sigma, right? That's how we convert x to z. So this 3.0 minus 5.1 over 0.9, that's exactly what we computed in one, right? Right? Where is it? Right here. 3.0 minus 5.1 over 0.9. We said that's negative 2.33. So here it's negative 2. So first, you do the top, right? 3 minus 5.1, that's negative 2.1. We divide by the 0.9, that's negative 2.33. Then there is z, and then the right side, 7 minus 5.1, it's 1.9 over 0.9. And we said that's 2.11, right? So that's 2.11. All right, I converted my x to z. Now, next step, I'm supposed to use the chart. But this is not the area to the left. This is not z less. This is not, it's not like z less. It's not z less. This is z between two numbers, right? So z between two numbers, wanna find the area between these two numbers. So how do we convert area between two numbers to areas to the left? Well, the idea is, so again, it's just, we have two numbers. This is 2.11 and this is negative 2.33. And you want to find the area between the two numbers, right? You want to find this area right here, right? So the idea is that the area between two numbers would be the area to the left of the second number. So the area to the left of this 2.11, right? Take 2.11. So this is the area to the left of 2.11, and you subtract the area to the left of the first number of the negative 2.33, right? This is negative 2.33. So this would represent the area to the left of negative 2.33. So you see the difference between the two arrows, guys? The difference between the two arrows, that's exactly the area between the two numbers, right? The difference, it's this one, right? This is the difference between the two arrows. And that's exactly the area between the two numbers. Okay. So what I am saying is that the area between two numbers is actually just the difference between the areas to the left. So you take the second number, you always take the second number, you take the largest number, which is 2.11. So z less than 2.11. So this is, again, this is the area to the left of 2.11. Left 2.11. All right, that's like my red, my red arrow. That will be the area to the left of 2.11 minus, and I subtract the area to the left, so z less than negative 2.33. That will be my green arrow, right? That will represent the area to the left of negative 2.33. So this is area to the left of negative 2.83. All right. Now, once we have everything expressed in terms of the areas to the left, now we can use the chart. Okay. Because again, the chart gives us only the areas to the left, not the areas to the right or the areas to between. It's just the areas to the left. So yeah, so to the left of 2.11, we said if you use the chart, that would be 0.9826, 9826 minus the area to the left of negative 2.33. We said, where is it? Right here, it's 0.0099. So this is minus 0.0099. right? And the difference, I guess, would be point, what is it? Yeah, 98.1, I guess, 5.01. Anyway, it's I guess it's so two places to the right multiplied by 100. That's 98%, 98.50%. Let's see. Any question, guys? So you see here, there is you read the exercise, you read the statement. You see the word normally distributed or normal distribution. You see the mu, you see the sigma, and then you have problems like less than or more than or between them, right? Then all you have to do is just convert this x to z, etc., and do this exactly the same thing as we did here. Okay, so normal distribution, mu is given, sigma is given, and the problems is like find the probability that something less or more or between. Okay, that's like the standard. That's like the standard problems we have when about this section 7.3, right? Any question?
Yes, Professor.
Yes,
Words
Steve.
come from
Yes.
98, 98, 1501.
Oh, that's the difference. I subtracted. So this is just the difference, minus. I subtract. You just subtract. So what I'm saying is you do the 0.9826 minus, of course, you need to use your calculator, right? Minus 0.099. You take the difference, the subtraction, right? It's minus. Okay.
I got something different when I subtracted. I got 0.9727.
Oh, 97.
Yeah,
Sorry. That's sorry. I guess I got.
Yeah, I got 9727.
Let
Yeah.
me see my. Okay, let me see my notes. Sorry, I got probably the. Let me see. Yes, you're right. Sorry, it's 97.
Yes.
Sorry, it's because I did different operation. All right, thank you. Yes, it's you're right. It's 0.9727, and it's yeah, it's 97.27%. Thank you. Any other question, guys?
Professor,
All
I
right,
have a
so let's-
question about
Yeah, please.
the last exercise.
Last exercise, the B, the number 2, you mean?
Wait.
Z more?
The exercise where we were talking about the murder.
Oh, yeah. I'm gonna discuss that, of course.
Oh, okay, okay.
Yeah. I'm gonna go over that in a couple of minutes. Yes. But let me just say. So, all right. So, for example, when you read the next exercise, so here, sorry guys, in the homework, it's a typo. It should be exercise 2, not exercise 3. But so in exercise 2, so it says like there is this X random variable represents the weights in kilograms of healthy adult female deer. Then X has a distribution that approximately normal, right? So next exercise, there's the word normal. So we are talking about normal distribution. We can see there is a mu, there is sigma, okay? So in exercise 2, I'm gonna just make just a couple of comments about exercise 2 because it's just the same thing. So so when you read the statement or the question, it says, so there is this the word normal, right? So we are talking about normal distribution. There is mu, it's given 63 kilograms. Sigma, it's given, it's 7 kilograms, right? And then it says the number 1, suppose that suppose the dough that weighs less than 54 kilograms is considered under nourished. What's probably the single dough captured is undernourished, right? So it's you want to find like the probability that X is, again, X supposed to be represent the weight in kilograms, all right? So X is gonna X to be less, right? It says suppose that weighs less than 54 kilograms, right? So X is less than 54, okay? So then we do as we did in the previous exercise, right? We convert X to Z, and then this is less, and because it's less, then I can use the chart. There will be no problem, right? And yeah, so this is exactly as the previous, exactly as exercise 1, first question, question 1, okay? Makes sense that this is exactly the same as the exercise 1, question 1, right? You see the word normally distributed, you see mu, you see sigma, and it says less, right? The weight is less. The weight is less than 54, right? So, all right. Hopefully it makes sense. Now, number 2. Well, here we see there is this n. So when you see the word n, the letter n, that's the size of the sample, right? So so this is 1. Now 2. So we have n. Parker Rangers use the rule that the average weight of n equal to 50. So here, and that's the size of the sample. So we have a sample here, right? And we have a sample of 50. So this is n is equal to 50. So it says, what's the probability of the average weight, X bar, right? It says the probability of X bar, the average weight. So it's not, so here it's not, we are not talking about X. Here we want to find the probability of the average weight. So it says the probability of, here just write the word, the problem in words. So probability that the average, probability that the average weight of the average weight X bar. So here you see the difference with the number 1, guys. Here we are talking about X bar. So it's not X anymore, right? Now we are talking about X bar. Okay, it says X bar for a random sample of 50 is less than 60 kilograms. So it says average weight X bar for random sample, etc. of 50, etc. is less than. X bar is less than 60 kilograms, right? So you want to find the probability, capital P, X bar, it's not X, it says X bar less than 60. So this is probability that X bar is less than 60. So this is the symbol for less. All right, so there is difference here with the number 1, because here it's not X, it's X bar. And so we need to convert anyway, because we're talking about normal distribution, right? This is, as I said, it says X has a distribution that is approximately normal. So we're talking about normal distribution here. So when we talk about normal distribution, then at some point you need to convert your variable to Z. But the thing is, here we're not talking about X, we're talking about X bar, right? It says X bar. So we need to convert X bar to Z, not X. So here it's, we need to convert X bar, not X to Z. And we said the formula for X bar to convert to Z, it's different from X. It's not the same formula. So Z would be like, say it again, sorry. So the formula for X bar is like X minus mu over sigma, not just sigma, but sigma over square root of n, where n is the size of the sample. Okay, so when you see X bar, you want to convert your X bar to Z because you have this normal distribution. then this is a formula you need to use, right? So this is, we discussed this actually in section 7.5. Anyway, so this is probability that X bar less than 60. So it's like 60 minus mu. What's the average? The population mean mu is 63, right? This is 63. That's the population mean over sigma. Sigma is 7.1. But it's not just sigma. Sigma over square root of n. Here, n is the size of sample. So here it says X bar for a random sample of 50. So it's 50, that's the size of the sample. So n is 50. So this is sigma over square root of n. Right? So you see the difference, guys. If you, when you see X bar, you have normal distribution, you see the word X bar, or I mean the letter X bar, or the symbol X bar, then you need to use this to convert your X bar to Z. So it's not just X bar minus mu over sigma, it's X bar minus mu over sigma divided by square root of n. All right, so then, just to do the usual thing, so X bar less, so this is good news because it means after we convert to Z, we can just use the chart. 60 minus 63, it's -3. 7.1 over square root of 50, right? And yeah, so then just compute this thing here, X bar, so -v. Now what's square root of square root of 50? If you check your calculator, use your calculator, that would be 7.1 over, this is 7.07, I think. Okay, so this is like X bar. So I think it's a good idea, guys, to first do the subtraction in the top, subtract the top. I got -3. Now try to compute the denominator. Denominator, it's the 7.1 over square root of 50. So first do the square root of 50, right? As you can see here, square root of 50, I said it's 7.07. And then we divide the 7.1 by the 7.07, which is 1.00. So it's -3 over 1.004. I'm gonna just take 1.00, right? So then this is X bar less than, sorry, it's not X bar actually. Sorry about that. Because I converted my X bar to Z, right? So here it should be Z, sorry. This is Z, of course. Less than -3 over 1 or 1.00. That's, of course, just -3. And as I said, so this is less, so we can use our chart. So here, chart or table 3. And of course here, just be careful, -3, it's the same thing as -3.00. Okay. And then, so nearest tenth would be -3.0, and nearest hundredth would be just 0. Okay. Any question about the number 2, guys, before moving to the 3 and 4? So you see, here there is the word normal distribution. You have your mean, you have your sigma. So it means that at some point you're going to convert your variable to Z. Now, sometimes you have your it's X, and sometimes like this number 2 here, you have X bar. So for X bar, you have a different formula, right, to convert to Z. All right, let me see the chat, if there's anything in the chat. There is something here. Okay, Nival, thank you. Appreciate it. All right, guys. So let me move to the 3 and 4. So 3 and 4, when you read the question, it says like for 3, it says USA Today reported that there's a typo, sorry, it's there's a missing T. But anyway, that 15% of all books sold are of romance genre. If a local bookstore sells 316 books on a given day, what's the probability that, et cetera, et cetera. So here, do you see the word normally distributed or normal distribution or the word normal? There's no normal, right? There's no word, the word normal, okay? There's no normal distribution here, which means that we have a different distribution, right? So in exercise 3 and 4 plus 4, okay, there is no normal, the word normal distribution or normal, right? Okay. So if you don't have normal distribution, there is the word normal distribution, it's not in the statement, right? So if you don't have normal distribution, so the other main distribution that we discussed is the binomial distribution. Okay, so if there is no normal distribution, then we are probably talking about binomial distribution. All right, makes sense. So you don't have the word normal or normal distribution, so it's 99%. It's just a not binomial distribution. Now, what's this binomial distribution? I remember in the binomial distribution we have this, this is the probability of success. There's a number of trials, so you have success, and failure, and then there's this P, which is probability of success. Sorry. So P, which is probability of success, capital S, and there's Q, which is probability of failure, which is 1 minus. All right. So if you don't have a normal distribution, there is the word, you don't have the word normal in the problem. So it's a binomial distribution. All right. Now, the problem with the binomial distribution is you need to know what will be a success, because in binomial distribution, you have this two possible outcomes, like a success and failure, right? So you need to understand what will be the success here. What will be the success? What will be a success in this problem? Because you need to understand what's the success, because you need to find the probability of success P, because that's what we're gonna use in our formulas. This probability of success P. All right. So here we are talking about books, and we are saying that 15% of all books sold are of romance genre, right? So here the problem is we are interested in the books, and in particular we are interested in romance genre, right? So if you take a book, so you take a book or select a random book, and you are interested in books of romance genre, right? So then if you select a random book, then either the book is going to be of romance genre or it's not, right? So that will be like your success and failure. You select a random book, right? Because we are computing probabilities here. When you compute probability, we mean we select a random, we select a random individual, and you want to compute the probability that the individual is, I don't know, something, okay? So you select a random book, okay? So either the book is of romance genre, or it's not, okay? All right, so my question for you guys, what's the probability of success here? Well, what's the probability that you select a book of romance genre here? If you select a random book, what's the probability that the book is of romance genre? Any guess what will be the probability of success, P? So this is my success when the book is of romance genre, right? and this will be a failure when it's not. So probability of success, it says, if you take all the books, what's the percentage of books of Romans genera? If you take all the books,
100%.
15, right? I'm talking about exercise theory, right? It says 15%. US Today reported that 15% of all books sold are of Romans genera, right? So that if we select a random book, there is 15% chance that the book is of Romans genera. So this P would be 15%. So when you don't see a normal distribution, usually you're gonna say like a percentage and a number. Like here we have this 15%, which is a percentage, and there is, and after that, there is this number 316. So the percentage, in general, the percentage would be your probability of success P, and the number would be your number, N, the number of trials, okay? So you need the P to compute wherever you want to compute. You need the P, probability of success. That will be the percentage in the statement, and then you're gonna have like a number, and that will be the number of trials. So that's the 316. You have a sample of 316 books, right? So this number of trials or the size of the sample, that's the number you have in the statement. So that's your 316. Well, if P is 15%, what will be Q? Well, Q, the probability of failure, it's 1 minus P, right? So P is 15%, or so percent, that's division by 100. So 15 by 100, that's 0.15. So then Q, which is 1 minus P, it's 1 minus 0.15. So that's 0.85. So Q is 0.85. All right. So let's do, I don't know. Well, I guess we don't have time to answer everything, but let's say you want to answer number 1. Okay, it says, so a success here, again, the success, that's when your book is of Romans genera, right? And the probability of success is 0.15. All right, it says, what's the probability that, so we have 316 books, of course, and on a given day, local bookstore sells 316 books on a given day. What's the probability that at most 50 are romances? Okay, so when you have a romance book, that's a success. So 50 are romances, that's the number of successes. You want to have at most 50 successes. So at most 50 are romances. So that's the same thing as saying at most 50 successes, because a success, that's when a book is of a romance genre. So at most 50 successes, at most, it means that no more than, right? The maximum number is 50, right? No more than 50. At most, that's no more than 50 successes. All right, maximum number is 50. Maximum is 50. Right, so you want to find the probability that, so the success is a success, that's R, that's a variable R. So when we have binomial distribution, we don't have the variable X, we're talking about variable R, the number of successes. So we want the number of successes to be no more than 50. So we want your R to be no more than 50, of course, it means less than 50, less or equal to 50, less or no more than 50, it's less or equal to 50. You cannot have more than 50, right? No more than 50, it's less or equal to 50. So you want to R, number of successes, to be less or equal to 50. All right. So we have this binomial distribution. You want to compute the probability that the number of successes, the number of romances is no more than 50. So we said it's less or equal to 50. So this is less or equal. It doesn't matter here, the equal. It's less than 50 or less or equal, doesn't matter. For the probability, it doesn't matter. You're gonna get the same answer. So it's less than 50 or less or equal to 50. All right. So how do we answer this? All right, so in chapter 6, guys, chapter 6, you know, we discussed this binomial distribution, etc. And to compute this, we had this table number 2. Remember this table number 2? Let me go to the table number 2. Right here, this table number 2. You see the table number 2, the first column, there is n. Like that's like number of trials, and there is r next to n. In the top, there is r, the second column, and then as you can see in the top, there's p, right? There's this p, etc. So yeah, we are supposed to use this chart or this table to find these binomial distributions, all right? But the problem here in our problem, in our exercise, the number of trials n. So let me get back to this. Yeah. So number of trials here, n, is 316. We have 316. We have a sample of 316 books. N is 316. Now, if you go to this chart number 2, which you are supposed to use to find this probability of successes, well, the largest value of n. So if you go to the next page, as you can see, the largest value of n, you know, it's 20. You see the 20 in the first column, you have 16, and then down you have 20. So the largest value here, if you're going to use this table to find this probability of this binomial distribution, you need your n, or number of size of the sample, or the number of trials, to be less than 20. Otherwise, it's not in the table. So our n is 316, right? So we cannot use this chart. All right, what happened here? Right here. Oops. Yeah. So we cannot use this chart. So the idea is, right, let's just, I don't know why it's taking time to open. All right, where is it? Okay, I guess I lost the board. Anyway, it's not a problem. So your n is 316. The probability of success p is, we said it's 15%, 0.15, and the q it's 0.8. So because n is more than 20, so we cannot use table 2. Okay, that's what we discussed in chapter 6, and that's your homework number, the previous homework number 5. So that was discussed in chapter 6, right? Now, what we said in chapter 7, or section 7.6. So if your n is large, is more than 20, so section 7.6. If n is larger than 20, then what we can do is there is a way to convert this r to z. If n is larger than 20, then we convert r to z. We can convert this r to z. So the idea is that your binomial distribution can be approximated by a normal distribution. Binomial distribution can be, when n is large, can be approximated by a normal distribution. So what we are saying, guys, even there's no normal distribution in this problem, however, because your n is large, this number of trials is large, then we can convert this number of successes to z. So we can approximate the binomial distribution by a normal distribution. You see the relation here, guys? So, all right, so we want to find, you see the board, right? Let me just check if, yes, okay, I'm good. Yeah, so we want to find the probability that r, number of successes, is at most 50, so less or equal to 50. Right? So as I said, actually we can use a normal distribution to compute this thing. The problem is, first, so first step, we need to go from R to X. This is R, number of successes. So we need to go from R to X and then from X to Z. Okay. Now the problem is to go from R to X. So there is R is equal to 50, right? R is less than 50, less or equal to 50. So that will be this. Come on. Yes. All right. So R is less or equal to 50. So that will be the area to the left of 50, right? So the problem here, there is a very small problem here. You want to include the 50, right? So less or equal to 50. You want to include the 50. So if you want to include the 50, the problem is if you just do the area to the left of 50, you won't include the 50. Okay. So you need to go a little bit to the right of 50 by 0.5. Here, 50.5. And take the area to the left of 50.5. And that would include the 50. Okay. So the border at 50 it's not included in your probability. So to include the 50, you need to go a little bit to the right. Okay. To the 50.5 to the right by 0.5. So then you can include the 50. You want to include the 50 because this is R less or equal to 50, right? So you want to include this 50. So what I'm saying, guys, so first you need to go from R to X, and to go from R to X, there is this continuity correction. So you need to move a little bit by 0.5. So in this case, because it's less, right? So you need to move your 50 by 0.5 to the right. So here your X would be less or equal to 50.5. Okay. Any question? So there is this first thing to do. You need to go from R to X. Then there is this continuity correction, right? By 0.5. All right, once you got your X, now you can go from X to Z using the same formula, to convert X to Z, right? So now I want to go from X to Z. So this is the probability that Z is less than 50.5, right? So it's supposed to be minus mu, right, over sigma. That's how we convert X to Z. Now, there is a problem here because there is no mu and sigma in this problem. But the thing is, we know how to compute mu and sigma for binomial distribution. And that was discussed in section 6.3. So section 6.3, we said in section 6.3, so mu, if you have a binomial, when you have a binomial distribution, mu would be n times p, okay? And sigma, we said it's square root of n times p times q, okay? So like here in this problem, n is, we have 316 books, so 316 times p, that's a 15%, or 0.15. So mu here would be equal to 47.4, I think. And here it's square root of 316 times 0.15 times point q, it's 85. Okay, which is, I think the answer here would be like, sigma would be like, I think 6.347, it's 3.4, 6.34. Right? So that's how we find this mu and sigma in this case when you have binomial distribution. They are not given in the problem. That's different from, the exercise 1 and 2, right? So when you have a binomial distribution, you have to compute your mu and sigma. So like here, that would be z less, probability that z less or equal. So 50.5, sorry. Mu 47.4 over the 6.34. okay? And then etc., right? You do the subtraction, you divide. This is Z less, so that's the area to the left. And then you can use a chart, table 3, and you get your answer. All right? Chart, table 3, etc. All right, we have like 4 minutes, and of course, any question first about this? So you see the difference between this exercises, at least exercise 3 and 4 and 1 and 2. So 1 and 2, you see there is the word normal distribution. So you have this variable x, you convert x to z, and sometimes you would have x bar. And to convert x bar to z, that will be a different formula, right? In 3 and 4, you don't see, there is no normal distribution in 3 and 4. So that will be a binomial distribution. Binomial distribution, you need the percentage of probability of success P, which is the percentage you have in the problem, like here 50%, and there's a number which represents in general the size of the sample N, or number of trials N. Like here it's 316. So if you go, for example, exercise 4 is the same thing, right? It says exercise 4, there is no normal distribution. It says like about 64, and I think we did the same example, exactly the same example or exercise in the lecture, actually. So it says in exercise 4, about 64% of the people who are murdered knew the person who committed the murder, right? You see there is a percentage, and then it says, suppose that the Detective 5 in New York, etc., has 65 current unsolved murders, right? What's the probability of that? So you don't see, there is no normal distribution here, right? So no normal distribution, just assume that's a binomial distribution. Okay, no normal distribution. So that would be a binomial distribution. A binomial distribution, you need P, probability of success. Of course, you need to understand a little bit what will be the success here. You need P, probability of success, and N. So what will be a success here? Just read the first sentence. It says 64 of the people who are murdered knew the person who committed the murder. So like a success here would be when the person who was murdered knew the person who committed the murder. Okay, that would be like a success. So that's your 64%. And then you have, it says you have 65, this number of unsolved murders. So that would be your size of the sample, N, or the number of trials. So P is the 64%. That's the percentage you see in the problem. And the next number would be your N. So you see 65, so that's your N. All right, in 2 minutes, I don't know if I'm gonna continue with this tomorrow, we'll see. But I think some of you asked me about number 3 and 4. So like 3, it says, so success here, a success, that's when the victim knew the person who committed the crime, right, or committed the murder, knew the murderer. Okay, that's a success. So in C, for example, it says fewer than 40 victims did not, it says not, right, know their murderer. Okay, did not. So if fewer than 40 victims did not know their murderer, okay, so the question is, because the success for me is that when the victim knew the murderer, right? So fewer did not know the murderer, the more knew their murderer, right? So the fewer than 40, so then more than the difference. So we have 65 unsolved murders, right? So 40 victims did not know their murderer. So then 25, more than 25 knew their murderer. Okay. So did not. So what you have to do is, guys, you have to take the difference between the number of trials. So this is 65 minus 40. So if fewer than 40 did not know, then more than 25 knew their murderer. Okay. And so that would be more than 25 knew their murderer. So that's probability that R is more than 25. In 20 seconds, guys, and probably I'm gonna go come back to this tomorrow. Let me just say for number 4, like for number 4, it says more than 40 victims. Again, 40 victims did not know their murderer, right? So then more than, then the opposite would be less, okay? Less than. So the difference, so here's 40 victims, right? Did not know their murderer. So the difference is we have 25. So then 25 victims did know or knew their murderer. So you have to take like the opposite, right? So it says more did not know their murderer. So then less than, and then take the difference. So 65 minus 40, that would be 25. They knew their murderer. Okay, so that's the probability that R is less than or equal to 25. Okay. All right, guys. I'm sorry, went over time. But anyway, I think probably I'm gonna continue with this tomorrow. I guess more details, and then as I said, we'll see. Either I'm gonna post the review sheet probably tomorrow. So either I'm gonna go start with the review for the test, or I will probably do one section in chapter 9, finish at least the 8.3, and yeah, and do one section. The sections in chapter 9 are kind of short. Yeah. Anyway, thank you for listening, everyone, and hopefully I'm gonna see you tomorrow. Take care, everyone. Thank you.
All right, take care, everybody. Take
Hi,
care.
Professor.
Yeah,
Bye.
thank you. Bye. See you tomorrow. Take care, everyone.
Professor, I would like to make sure that you make me present because I came a little bit late.
Let me see who's talking. Oh, Jessica. Oh, got
Jessica?
you. Thank you, Jessica. Thank you. Got you. Thank you.
Okay, thank you, bye.
Bye-bye.